My name is Garrett Serac. I work at Microsoft. Let me just start this up here. So there's me. I work at Microsoft. I've been at Microsoft for about 6 years, and I work in the what's called the Open Source Technology Center. And our job at the Open Source Technology Center is actually to help Microsoft work better with open source software and help open source software work better on with Windows and improve support for it on our platform, and help product groups actually make connections with open source communities and build relationships so that we can get everything working in a nice way. So people often ask, well, why are you doing this? Why are you guys getting involved in open source? And the number one reason is because customers want open source software. They want to be able to use their software, what they want to do, on any platform. Sometimes they need to use it on Linux, sometimes they need to use it on Windows, and they need to bring these things together and get them all working. And so this actually gives customers a choice. So rather than forcing customers to say, oh, well, because you're a Windows customer, you can't run this particular piece of software, or because you're a Windows shop, you're not going to get into this, that's not acceptable. And so helping customers get access to open source software on Windows is both good for them and good for us. And then customers can use whatever's best for their business. If they want to use Drupal and they want to do it on Windows, hey, that's great. If they want to use Drupal and they want to do it on Linux, well, that's great too. So we started working with these communities, and we started working originally with some developers in a variety of different places, and we started with working with Linux. Actually, we started with working with Samba, and helping get Samba running well with Windows and things like that, and make sure that there was interoperability between Samba and the Windows stack. And we started working with Linux, and we actually do things like the Hyper-V drivers for Linux, so that you can actually host Linux under Hyper-V on Windows. And then we started getting into PHP a few years back, and I started working on as a PHP committer and helping fix things in the PHP stack on Windows, because it turned out that there was a large gap between the functionality that we'd find on Windows and not on Windows. And so PHP was actually a perfect example of something that we wanted to try and get working better, because PHP itself, it has many, many dependencies. The build on Windows has about, 25 or so different libraries that it depends on. It's in widespread deployment. People use it both for development on Windows, and some people actually use it in production. And it was getting very popular. Obviously, a very large portion of the web runs on PHP applications. And it's also continually evolving, so it's not something that somebody built and just left by itself. It's a moving target, so this is actually a great thing to take a look at and go, well, how can we help make this better, and what do we have to do? So at first, we take a look at how we build things on Linux. And on Linux and on Unix, we have things like autoconf, which, a nightmare as it is, it does serve one very important purpose, and that's making it really, really easy to compile our software, or compile software on Linux. And essentially, this is so similar between every piece of open source software you get. You grab a tar file, you unpack it, you go into the directory, you run configure, you run make install, boom, it runs. This is awesome. This is the way that this stuff was designed, obviously. Now, on Windows, of course, we don't have automake or autoconf. We don't have these tools. And worse yet, this is Windows, not Unix, and this is a pretty important thing to look at. We can't just simply say, well, let's port autoconf to there, because the whole environment is different. We have we have a lack of standardized libraries, and on Linux and Unixes we have libraries that are built in such a way and placed in such a place that it's easy to say, well, here's where we go to look for them, here's where their header files is, here's where the libraries are. We don't have any of that on Windows. And worse yet, we actually have multiple different compilers to deal with. We have VC6, 7, 7.1, 8, 8, 9, and VC10, plus we have GCC, and then there's the Intel and Borland and whatever. And the problem is that those introduce different compatibility issues that you never see on Unix, because you tend to focus on one particular compiler, and when you need to rebuild stuff, everything builds nicely, so it's easy enough to say, well, rebuild everything. So we started off actually working with PHP and trying to rebuild all of the dependencies, because between 1998 and 2008, in 1998, somebody sat down and built a bunch of libraries for building PHP. And what they did is they actually just took and compiled them up, stuck them in a zip file, and that zip file was passed from developer to developer in the community for a decade. Nobody updated those libraries, there was no security fixes, no functionality fixes, and consequently it was a really lousy experience. And so in 1998, the community and Microsoft participated a little in this, and we sat down and tried to rebuild all of these dependent libraries. And each one of these things had a different build script and a different way of building it. Some of them had make files, some had VC6 project files, some had a batch file somebody wrote to build these things. They were all so different. There was no standard layout, there was no standard way that these things got written to disk or where they were going. And really there was just too few people involved. The number of people that were interested in maintaining this was, on the whole planet, well, less than 10 really, which is really shocking when you think about the number of Windows machines in the world, the number of PHP developers or people who are interested in PHP, and the fact that this is in the hands of, a carload of people. There's so very few people working on this, and of course, they're trying to keep up with everything, and so everything starts getting dropped, and there was nothing getting done. And so in the process of actually figuring out, well, what do we need to do to make open source software build right on Windows? After doing a bunch of these libraries on Windows, I sat down and said, this isn't right. This is something that's going to take us forever to catch up. We're never going to get ahead of the curve on this. We're never going to be able to say, oh, well, when the new version of OpenSSL comes out, how do we get to that one? Or how do we make sure that we're using that? And we were just setting ourselves up for another failure several years down the road when we had to catch up. And so we just had to stop and say, we can't continue like this. We have to stop and think of a better way to do this. And then, I was working with this stuff, and then it started hitting me as to exactly what we needed to be able to do. And so what we need to ask ourselves is, well, what did we really want out of this? What are we actually looking to do that we want to be able to do in a sustainable way? And really, I want a frictionless way to compile, publish, and consume open source software. I want to be able to make something, and I want to be able to use it, and I want to be able to give it to somebody else so that they don't have to try and figure it out for themselves. And that's really one of the critical failings of open source on Windows right now, is even if I can figure out how to build something, and I build myself a copy of OpenSSL, and of course OpenSSL has a dependency on zlib, and if I go and build both of those, there's no common place to find these things, so chances are if you're going to go and do the same thing, if I get around to publishing, here's how I did it, you're going to replicate the steps at the very least, and that's suboptimal. And so when I speak of frictionless, what is it that I'm actually talking about? And the first thing that I'm looking at is availability. And this is really the key feature, and is that have they identified the right product? Do you know what it is you're looking for? Does it exist? Can you actually get your hands on it? And finally, can you find it? Again, this is a critical failing in the way that things work on Windows and open source, is that if you're looking for an OpenSSL binary right now, what's the quickest way to find one? Well, your first instinct might be to go to openssl.org, and you'll find that they don't have binaries there. Well, then what do you do? Well, then you go over to the Google and you start looking, oh, where's this? Do we have, does anybody publish a binary? And you'll find some guy somewhere sooner or later that does. Is it the most recent version? Chances are no. But it's very difficult to find it. Now imagine having to do this for all 25 libraries you need. Starts to get extremely difficult. The second thing that's really important to look at when we're talking about frictionless is reliability. And is it well adapted to the platform? Is this something that I'm going to be able to run and I'm not going to be going, oh, this thing runs like garbage? Or is this something that's going to work really well for me? How simple is it to keep up to date? So even if you were able to find it, you said, oh, I know where this binary is kept, I'll go and grab that, I get it. Is somebody keeping that binary up to date? Is somebody actually going to make sure that you have the ability to get an update when a critical security fix comes into OpenSSL? Well, it happens often enough, so you'd better hope so. And then when it does break, can it be fixed? And if somebody can show me a piece of software that never ever breaks, well, I'll show you software that nobody ever uses. And as we well know, that these things we're going to uncover problems and bugs and errors inside the software. And the question is, how fast can we get it repaired? How fast can we get it back to the state where we need it to be in order to continue running? And finally, the last thing that I like to talk about is consumability. If you knew how much work it was going to be to use it in the first place, would you do it again? And I like to say this one because this is what, so many things in my career in IT, I've come to something and I do all this work and it's like we get through it and it's like, well, if I'd have known how much work it was, I'd have never even tried that. That was just, way too much effort. And if it takes too much effort to consume a piece of software, then it's worthless. There's no point in getting involved. And what can be done to eliminate these barriers? Is there something that can make this easier? If installing it requires you to jump through hoops, has anybody here ever installed, WebSphere on Windows? No? Yeah? Oh, my apologies. That is horrible stuff. You have to walk through, it takes you hours and hours of pain and suffering. You get to the end and you're like, did this work? I don't know. So then as we start looking to move to this sustainable solution, what are we going to do in order to make this actually work right? Well, the first thing we need to do is actually build better software. We need to look at the build process, and we need to say, I need to be able to make sure that I can reliably take these bits and get out something useful. I want a binary that's going to be useful to me and anybody who wants to consume that binary from me. The second thing we need to do is be able to package it. We need to put it in a format that everybody knows how to consume or can consume with trivial nature. G-zipping up something on Windows is probably not the best way because the first thing you need to do in order to get that is actually go find something to unpack that. So we need to make sure that we're not introducing more complexity just in order to use something. And finally, we need to be able to share it with everybody. We need to be able to provide it in a way that everybody can find it, can use it, can grab it, can access it, and we're not replicating work. And again, I come back to this point about replication of effort. When somebody builds a copy of OpenSSL, they use it for whatever they're using it for. And a perfect example of this is Adobe Photoshop. Actually, Adobe CS5 comes with 14 copies of zlib. You install Adobe CS5 on your hard drive, you go look, and you'll find 14 different copies of zlib. So their own company isn't even sharing libraries amongst themselves. And this is horrible. This is like, why would you not be sharing these libraries? And it's because there's no common and standard way to put these things together, and there's no place to share them. And this introduces other problems, like if I build a binary and I don't, let's say I build a browser plugin for some twisted and strange reason. And you download it, you install it, oh, that works great, and it's got OpenSSL embedded into it. And then somebody else builds a different browser plugin, and they download and install it, and it's got a different version of OpenSSL installed. Well, this starts to cause the opportunity for problems to start cropping up. Now, of course, they've eliminated a lot of these problems with, process separation in browsers and stuff like that. But the fact of the matter is there's a lot of software that this doesn't work with, like Apache on Windows. If you have things that run in process, you can have multiple versions of the same library loaded at the same time, or try to, and really what's going to happen is they'll collide and sometimes things will break. And so how do we go about building this better code? And what we really need to do is actually start creating shallow forks of a whole bunch of software on Windows. And so when we say, well, let's take zlib, for example. Let's not just take the source code and put it in a place. Let's create a shallow fork so that we can make any minor changes that we need to and still push them back upstream if possible. But if not, we still need to maintain our own branch. And the great thing is that places like GitHub make this extremely trivial for us to create shallow forks and work on them and keep them maintained and up to date. But we want to make sure that we have a place and a series of steps that we can follow to have a consistent way of building these things. The second thing we actually want to do is actually automate the build process. We want to create consistency between projects. I don't want to have to check out a piece of source code and start searching through the source code source files in order to find out, well, did they give me a make file? Did they give me a project file? AutoMake and AutoConf on Linux takes care of this really well. It just builds a make file and everybody uses the same format, or CMake or whatever. And so what we really want to do is actually automate our build processes so that these things are consistent. We don't necessarily have to change it. What we can do is we can wrap up the existing build process and make sure that this works in a consistent fashion. And this also lets us increase agility. So if recompiling something is not hard to do, if rebuilding it is going to be trivial, we can check it out, do a build. Oh, if we change something, we can check it, we can do an update and build again, and no problem. If the command is the same for every piece along the way. And finally, this will eliminate this duplication of effort. Once somebody figures out, well, let's build it or let's set up the build process so that this generates code in a consistent way, then you're not going to have to figure out the next time. You're not going to have to go, well, what did that guy do, or what did he leave out of his instructions? If it's all automated, then this should be trivial to have everybody participate. The next thing we want to do is actually start leveraging some of the powerful features in Windows. The first thing that I like to bring up is one of the most powerful and useful things in Windows that absolutely nobody on this planet seems to know about. And that's the ability for Windows to have what's called side-by-side assemblies, or side-by-side DLLs. And this is a feature that's built into Windows and has been there since Windows XP. And this allows the system to manage shared libraries. And so if I've got a version of OpenSSL, I can give it a version number and by a particular publisher. And when I link to that piece of software, I can install updates to that library, and the software that relies on that thing ends up using the most recent version of the same binary compatible version. This allows updates to be applied and to be able to find the right version at all times. This also allows us to have multiple concurrent versions of the same library installed in the system and not applied. This eliminates DLL hell. It eliminates the confusion as to where these things are stored and found and looked up. Now the downside is that the documentation for side-by-side, while perfectly accurate, does not tell you how to use it. And I spent many months trying to decipher exactly how this stuff works, and I have access to the engineers who wrote this. And it's funny because there's even parts of Microsoft where they did not figure out how to use this correctly. And a perfect example is Visual Studio. In Visual Studio 7, 8, 9, they shipped their C runtime library as a side-by-side DLL. Unfortunately, they did not understand exactly how to use this correctly either, and it was very much a pain for the end user because if they didn't have the right version, nobody knew why it didn't work. And so what I started doing was figuring out, well, how are we going to make this so that this feature can not only be used, but used by developers without having them to spend months and months trying to understand it. And so that was a very important thing. And then, the .NET Global Assembly Cache is actually the same sort of thing, but for .NET. But there it's a lot simpler to use. The next thing we want to make sure is that when we install software, that in large organizations, so in enterprise situations and whatnot, that people can use group policies to manage that software. Because it's very important that we make sure whatever solution we come towards ends up working for everybody and in the way that they're expecting it to work. And this is important because this affected, when we started looking at, well, how do we want to design this, we said, well, I don't want to just take, say, RPM and get this working on Windows because none of that stuff is native to the way Windows works, and you can't use native tools to support and manage that because we'd have to write them all, and what's the point of duplicating the effort? And so finally that led us to Windows Installer, which if anybody's ever used Windows Installer and built MSIs, either using Wix or using something like, well, some commercial tool, you curse and swear at it because it's the most convoluted and complicated thing. This is actually a lot similar to side-by-side in that regard, in that there's a piece of technology which at its core actually works pretty good, but it's so complex that nobody understands how to use it correctly. And then over the years, they keep tossing a bit more functionality on top of Windows Installer, and it's gotten a little out of hand, and so you end up with these awfully complicated installs. And one of the things that I like to look at when I install things is how many questions did they ask me? When you install, let's say you go to the command line, you install PHP on Linux, how many questions does it ask you? Well, none. You say, I want to, RPM install, whatever. I install the package and it works. It didn't ask me, well, where did you want to put it? Where do you think I wanted to put it? It was supposed to go into and it doesn't ask you over and over and over. And software on Windows, this idea of let's ask questions of the user at install time is such a pain because, well, what if I needed to install like 30 things? What about 50 things? What if I needed to do this on 100 machines or 1,000? How many times do I have to answer the same question? And they say, oh, well, then you can build this automated install script. It's like, why doesn't it just install? So from my perspective, Windows Installer does an awful lot right, but it also does a few things where it lets the end user get awful confused. And so what we want to do is make sure that when we use those features, we don't introduce complexity, we actually introduce simplicity. And then finally, what we actually need to make sure is that we actually target multiple compilers. PHP from version 5 or from version 4 point something all the way to 5.2 something, which was to span the decade of 1998 to 2008, was built with VC6. VC6 shipped in 1998. So 10 years later, we were still using a cost individual developers money. It's okay if you're an organization, it's okay if you're, like the Apache Foundation or the Eclipse Foundation or Outer Curve Foundation. It doesn't matter, $100 or $300 for a certificate for a year is not going to hurt them. But if I'm publishing my own binaries, $100 out of my pocket, I don't want to spend that. I'm too cheap for that. Grab a microphone. Hello.
Mic check.
Rock and roll.
I'm from the CASET project, so if you use CASET certificates, you can use them for free.
Absolutely.
So it's better than using self-signed ones or something.
Absolutely. So self-signed certificates have very little value. All a self-signed certificate says is that when I get another version of the software from the same person, I can be assured that it's probably the same person that gave me the last version. It doesn't tell you anything more than that. So he brings up the idea of using CA cert, and we had been talking in our mailing list for the coapp mailing list about what we were going to do about this self-issued or getting certificates for individuals, and we had considered actually starting a CA for the project, and then here just this last week I'm like, well, wait a minute, there's CA cert, and I was actually going to come and talk to you guys yesterday, but I got tired and I had to go take a nap, and so I was going to come go talk to you guys. Hi, just spilled my water. I was going to come and talk to you guys after this talk, because what I want to do is take CA cert's root cert, and when we install the package manager for coapp, is install the root cert right away, so that we can then say, well, now we trust all the CA cert, or that we can have an assurance that we can use those certificates without having it come up and give you warnings all the time and stuff like that. And essentially, that's a really great way to make sure that we start this idea of going towards a web of trust for digitally signed software. Currently, I'm not a big fan of the way that the certificate authorities work, and it's not like they're giving us any trust anyway. So what we want to do is provide a mechanism for being able to identify these certificates, or identify who's published a piece of software, and decide for ourselves whether it's useful. Regardless of how we actually get to that point, the first step is making sure that everything that we build with coapp is always digitally signed by somebody. This gets us the first step and gets us closer to figuring out whether we can identify over these reliable binaries. Where are we now? So a packaging standard. So then the next thing we need to do is actually make packages that are built according to a standard. So rather than just letting everybody make their MSI file with whatever tool that they want to make these things, we want to make sure that we can find something and be able to have the right kind of information in the package so that we can consume it. And so we want a packaging standard that allows us to build applications, shared libraries, developer libraries, heck, even source code. There's no reason why we can't, on Windows, use MSI files to just deliver us the source code for a given build of software, so that when a developer who is maybe not familiar with open source technologies looks and says, oh, hey, I can get the source code for that, and within a single click, downloads the source code, and maybe he's a Windows developer, maybe he spends all his time running in Windows and he's never been much into open source. This might help us get an additional person working on open source if we lower the barrier to grabbing the code and just letting him play with it. And then the next thing we want to do is make sure the package metadata has all the information in it that is required in order to be able to get the dependencies and the publisher information and the cosmetic data. So when the package is delivered, you should be able to inspect it with some tools or something like that and say, well, what is this? And where is this for? And what does it depend on? Who built it? Do you have a description, an icon, whatever? Those kinds of things should all be embedded in the package in a consistent way. And then we have to move to this point about sharing. We need to be able to build packages for sharing, and this is going to, things like developer libraries. And I've talked about this already, about all these packages need to be something that somebody else can pick up and use, and they need to be updatable and reliable and all that, blah, blah, blah. What's most important about this, though, is that we need to make sure that these are easy to, that systems can find these. And the way we do this is what we call package feeds. And our package feed format for coapp is actually an atom-based format. So you can actually just use a web browser to go and look at this thing, and you can see, oh, here's the stuff that's in it. And it's formatted in such a way that it renders nicely with just a web browser, which at least gets you some information that you can use. Add on top of that, our project itself actually has access to a CDN based on Azure, which is really great, because my employer seems to think that what I'm doing has value, so they're willing to spend vast sums of money to help me out in that regard. And so we can distribute packages across the globe with no worries about bandwidth or stuff like that. And our package feeds also need to be able to work on a very small level. If I give you a piece of software on a disk, I want to make sure that I can give you everything that you need to be able to do to install there. If you want to be able to stick it on a USB drive and walk up to a machine and just plug it in that doesn't have network access, it needs to be able to have everything contained locally. And so our package feeds work both from a file-based, they work across the web. They're actually embeddable inside the MSIs as well, so that an individual package's metadata actually has a small feed inside of it, which is just essentially the feeds, the feed items for all the individual pieces. And so this scales in both directions, up and down. And then so fulfilling the end user. This is the what do we need to make sure this is happening for all of these end users? What's the thing that we need to make sure? Well, the first person that we need to satisfy is developers. And a lot of the times people will build, and this happens on Windows, if you looked at the alternatives for package development or package management or building things like this and relying on other stuff, they seem to have made the worst experience for developers, which doesn't really make me want to use it. As a developer myself, I don't want to go through tons of pain and suffering to be able to use this. So developers have to be very critically taken care of. The next thing, of course, is IT pros and admins. We need to make sure that people installing the software in production environments are willing to use this because it's simple and straightforward and doesn't require them to be a developer. They don't understand code in the way that developers work on it, and they shouldn't have to just in order to install stuff. It shouldn't require a PhD in order to figure out how to install PHP on Windows. And then finally, desktop users. This is actually the third category, and the reason why these people are actually less important than the other two is because they're somebody that we don't have to target today, but as we get further down the road, we can make sure that their experience is awesome and easy to do. But end users, like desktop users, don't necessarily care about, well, what are all the dependencies for Firefox? How many things did I need to download in order to get that? What are the dependencies for PHP? They really don't care. They're more interested in it from a product perspective, and so they have a slightly different view of what they're looking at. And we want to make sure that their vision or their view of the way the packages is more product-based and applicable to their needs without sacrificing the work for developers. And so the way we're going to actually get to these spots is we're going to need to actually start providing the packages that everybody needs. And so the coapp project itself has started shallow forking many pieces of software. And our goal there is to actually provide the low-level libraries that things depend on. And PHP is, again, a great example because my employer seems to care about PHP. And if I wasn't working on this, they'd be having me continue working on improving PHP itself. So they're very interested in that. And so if I'm running after that goal, they're more willing to pay me for my time to continue working on this project. Hello, machine, there we go. And so PHP's dependencies on Windows is this list here. Actually, this is PHP and Python. I think there's two things on here that are really for Python. The rest of it's all PHP. And the funny part is that there's this massive list of libraries that if I had every one of these in a consumable, easy to update, easy to acquire way, well, if you look at that, if you're thinking about a piece of software that you build, chances are most of the libraries you depend on are on that list. And if there's something that's not on there, it's probably, once you had all of these things, not so hard to get it to the next step. And so what I can do right now is I can show you a quick little demo of what working with coapp looks like. So what I have here is I actually built a couple of packages. Get my mouse out of the way. I have a couple of packages here. One is the coapp toolkit, which is actually the core package manager. And both these are distributed and the other one there is the dev tools, which is actually the developer tools we use for building packages and things like this. So the great part about this, I can actually run either one of those MSI files, and coapp will get installed, because what happens is that any any coapp MSI package actually has a small little bootstrapper in it. And so when you go to run that MSI, the first thing it goes is coapp installed? Oh no, let's go and grab that from the internet and install it first. Now I'm going to actually install the toolkit directly rather than relying on the thing to try and download download it. So here I go and run this thing, and the first thing you notice is that I didn't get asked any questions. It's not going to bug me about stuff. It's going to actually get to this point, and what it did right there is it made sure that I had all the prerequisites, and boom, the package, now it's saying, here's the installer for this. This is the one and only screen you will see for every single coapp package if you install it directly. You just run the MSI, this is the one and only screen that you're going to ever see. You're going to see the title at the top, you're going to see the version, you're going to see the name, you're going to see a short description, and then the important thing is that automatically upgrade to the latest version available. The checkbox is by default checked, so if you grab an old version of, say, Firefox, you double click on the icon, it will start the installer, it'll pop this up, and then it'll go check the feed across the internet for wherever that thing came from, and say, oh, there's a newer version, and it'll actually display the information for the newer version rather than the one that you just clicked on by default because that checkbox. If you uncheck that, it'll say, oh, you just want to install this specific version because apparently you know something that somebody else doesn't. And in this particular case, the coapp package manager, because it bootstrapped itself during the install of itself, the install button is actually grayed out right now, so I can either remove it or cancel this thing out. So let me just go and cancel that one because I don't need to install it now. And, well, I can run the other one, the coapp dev tools. And what you'll notice here is, ta-da, there we go. So this is the coapp developer tools. This is the one that I'm about to publish in a few more days. And it's got two buttons and it's got the one checkbox. And so I'm going to say, yeah, let's install this one. It goes and two things. One, that was really fast. Coapp packages tend to install really quickly. Why? Because we don't have a lot of crap in our packages. We don't force the user to go through a bunch of different screens going next, 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 next. And by the time you get through the registry. And the second thing is when it was done, it went away nicely and didn't bother you. So the idea there is that installation doesn't become a chore, installation doesn't become painful, installation is just something that happens. And so now I can go to the command line and I can say coapp list. And eventually come back. Hopefully this version doesn't crash. This is still my work in progress. There you go. So now I can actually see the packages that I've installed, what version they are, and the location. If they're not installed, it will tell me the location where you find them.
One question, is it possible to avoid this screen and use the one So there's the famous /silent.
So silent, yes. So yeah, silent installs are definitely on our list for March.
So this still does not support avoiding this thing?
Right as of this moment today, no, we can't, the silent install doesn't work, but you can do it from the command line. So if I wanted to say coapp, remove dev tools.
Can you use a different color?
Oh yeah, sorry, let me see if I can't. Let me see if I can't figure out how to change the color on this quickly. Oh, nope. There we go. Ta-da! There we go. So, apologies. That's it. Come on, stop that. Okay. Now what did I do? Oh. Coapp list. Coapp list. So right now, if you want to be able to install without having the UI show, I can actually just go coapp install and that same package, and it'll go ahead and install that one directly rather than showing up the UI at all. In the future, like in about a month or so, we'll actually make it so that you can just do a MSI exec/I and install something without the UI popping up at all. So making sure that we can do this in an unattended fashion or headless fashion is very important, especially for things like being able to install these things on Azure, which you don't actually see the UI when things get installed and have no ability to go, yes, please install this. So that's a pretty primitive little view of what we're doing so far, and really there's not a lot to see because we don't have to show a lot of things. I mean, we can, coapp itself has a few commands, and we're still working on some of what this stuff works for. And of course, it goes really slowly on my laptop today. But that's pretty much my little demo there. And so our actual goal is to support open source software on the Windows and Azure platforms in a frictionless and sustainable fashion. We want to make sure that when we're building stuff, this is going to be easy to use and will continue to be easy to use. Our projects, all of our source code is Apache 2.0 licensed. So you can use it wherever you want to. We've got quite a lot of code there already. Developers retain their copyrights, so it does not require people to assign their copyrights to anyone. They retain their copyrights, but it's Apache 2 licensed. And Microsoft participates in the development. So here's a really key point about this project is when I started this, must be almost 18 or 20 months ago, I went to great lengths to make sure that Microsoft was just a participant in this and not the owner of this. So all the code that I've contributed to this, which they pay me to do full-time, I work on this project full-time right now, Microsoft does not own. Microsoft does not decide the direction we go. The community as a large gets to decide the direction we're moving. Our community has made a lot of decisions, some of which I did not think was, it may not have been in my original vision, but I think that we can come to a consensus that this is the best way to do a particular thing, or these are the features that are important. And we followed our direction as a whole from our community. So the coapp community owns the responsibility of maintaining the tools, repositories, and packages. Now, if you want to build your own packages and you want to build your own repository, no problem. It's really trivial to do so. We have tools that make it easy to make a repository, and it's just essentially you can just host an XML file in a web server, and the package is on a web server. So where are we at? So right now, we're going to hit beta 3 this month. I was really hoping to get it done before we got to this point, or got to FOSDEM, but it wasn't possible, I'm sorry. But we're going to hit the beta 3 by around the 15th or the 18th of this month. We're going to have our beta 3 release, which at that point in time should be very usable. We should be able to make packages. People should be able to rely on packages. Our shallow fork repository, our repository of shallow forks is going to be well underway, and we'll have quite a few things that are ready to go there. And then we're going to hope to hit release candidate about a month later and our 1.8 release. So then the future direction, I mean, I've got a million ideas about other things that we can take on here, right? What great UI can we put on there so that people can discover software? What great things can we have so that developers can make this job easier? My job right now is to make open source software run better on Windows. That's my official job description. And the way that I intend to do that is making tools and technologies that are open source that we can use on Windows to make this process simpler. I look at this coapp project, and regardless whether Microsoft continues to pay me to work on it years from now, this is really a lifelong pursuit for me, and is going to be something that I'm going to be continuing to do whether they pay me or not. And so to continue on this track is important. So then the question is, can you help? Ways that people can contribute. We need developers, we need publishers, we need documentation. We need people who can help us out in a variety of ways. We've got an actually not bad website now. For a very long time it was lacking, desperately. I've tried to fill in documentation, but as the primary developer of a lot of this stuff and the guy who's thinking this stuff up and getting paid to do so, I don't have enough time to document everything that I do. So if you're good with, developing, if you're good with C#, hey, I'd love you to be on board. There's a bunch of tools that I think we can build that'll make this even better. If you're good with C and C++, we want packages. We need to be able to do builds, and we have a process we're working on so that we can say, here's what we do in order to make a good package. Here's the steps we follow. Here's how we shallow fork something. I need your help. And, or other things. If you have, spare developer cycles, you have some guy who's working, we could use some help because this is important. And this is going to help everybody, right? This helps you as consumers. This helps you as developers. It helps you as IT pros. So when you want to find out more about coapp, you can actually check us out on the web, coapp.org. We got a nice little pretty website, which I hand wrote using Node, some stuff with Node.js, and yeah, so my website right now, coapp.org, is statically generated using Node.js and a document system called DocPad. You can also check us out on GitHub at github.com/coapp is our organization, and we also have coapp packages, which is our collection of shallow forks, and we're at about 60-some shallow forks. And some of the stuff you're going to look at and go, what are they thinking? And it's, you know, you need to read some of the documentation on the web, you need to read some of the stuff that we're working on that helps you understand the direction we're going and how this stuff works together. And we're also on IRC on Freenode in the coapp channel. And if you're having questions or whatnot, I'm there 7 days a week, just about. So, and if I'm not,Ll be there soon. So go ahead and come on and ask some questions. And so, thanks. I really appreciate the opportunity to come and talking to you folks out here, in spite of the nasty cold. And is there any questions? Do people have anything they want to know more about? Yeah, we have the microphones up that if you have some questions.
Simple question. Backup managers like RPM and Debian package managers have a facility to distribute the source code of a package along with the binary version.
Right.
Has coapp?
So our intent is to actually build source code packages along as well. Our metadata contains information that says that can contain the URL for the source package of something. So when you build a binary package, you can also provide a source package. That sort of support probably will be next month in March. I will have that stuff in there. But yeah, absolutely. Source packages are very important, especially because a lot of Windows developers, a lot of people who are really good developers on Windows don't understand Git, Subversion, or CVS. I know that seems really alien to everybody in this group, but there's so many people on Windows that don't understand some of the tools that we take for granted, and so source packages are extremely important. That gives them the ability to experience open source in the same way that we do.
Okay, and can I ask another question? You just said that it wasn't you won't port AutoConf and AutoTools to Windows. Is there some other initiative to make building open source software on Windows easier?
So as part of our tool set that we're building, so he's asking about AutoConf. As part of our tool set that we're building, and I didn't have enough time to go into depth about this. I actually have a set of tools which are called Trace and Make Spec and Make Project, and the goal there is to be able to, if you can build it once on Windows, I have a tool that can watch your system while it builds. It identifies, oh, it spit out this exe and this DLL and this library file, and then it can trace backwards through the processes, figure out, well, what object files went into those? Oh, well, what C files went into those object files to make these things? What command lines were used to build that? And we can take all that information and feed it through the other tool, which is Make Project, and it can spit out brand new Visual Project or Visual Studio project files for VC6, for VC9, for VC10. And this lets us build nice builds of things without having to figure out so many things about how the system works. And so that is going to be the equivalent of our auto tools, and I think we're going to get to that later this summer. I started working on it last year, and then I ended up spending way too much time on the package manager. So,
Thanks.
Thanks.
I guess that sort of answers my question. I was going to ask, is it possible to build, if I got my technology or terminology right, Arch all packages on Linux? I.e., can you build a package that can run on any architecture, like a Python script or something similar, on Linux and then deploy it on Windows?
Oh, and can we build packages on Linux and deploy it to Windows? So, you know what's really funny is that about 3 months ago, this question started becoming really important. And it was funny because up until then, none of the people in our community really thought this was significant, and all of a sudden it's like, well, how could, you know, and this becomes really important with things like web applications like Drupal, WordPress. Developers there don't work on Windows. They don't care to work on Windows. And so today, unfortunately, we haven't got a plan on how we're going to be able to build packages not on Windows, but we're thinking about how to accomplish that. That is one of our goals that I'd like to see happen in the next year or so. I'm hoping to figure that one out. If not, we're going to try and figure out the simplest way I can make that happen.
Okay.
I was actually going to ask the same question, and my suggestion would be to make available a build server that allows people to upload their source and check whether it works with coapp.
And so, yeah, so what we can do, and so for a lot of that stuff, if it's open source software and you want to be able to build a package for it, we're going to, we have actually, I have virtualization servers and I have build servers which have 7 different compilers on them, GCC and all these different versions of VC. And we're putting it together so we can build, to do automation for all of this stuff. And so that is one option already, is that we can actually just, you can check it into GitHub. If you put it in our coapp packages organization, we intend to build it, package it, and support it. So that's one option for non-Windows developers too.
If I give a package to someone without web access, will the bootstrapper, will that fail, or is there a way to support?
If you don't have web access, yeah, so if you, the bootstrapper is very clever. It starts by looking around on the current system to see if it can find the installer for the coapp package manager itself. So if you drop the MSI for the coapp package manager in the same folder, it'll find it right there and it'll go ahead and install it. You can also, it's configurable as you can tell it where to find those things. You can put a server up locally if you want, and by group policy you can push down a registry key that tells it where to look locally. So in an organization you can say, well, nobody has access to the internet, but our local server is here and this is where you look to go and grab that information. But yeah, it can look in the current directory, it can look in some common locations, it can look in a cache directory, and then it tries to find the best, most appropriate way to find it. You can actually even store it inside of an MSI file itself, so if you wanted to make a monolithic installer with all of the dependencies inside, we plan to support that as well. Okay.
How do you avoid DLL hell?
How do we avoid DLL hell? Well, that's where Windows side-by-side technology comes into play. Windows side-by-side makes it so that we can have multiple versions of the same file or the same DLL installed at the same time, and the system knows how to find them because there's manifest information that gets embedded in executables. Say, I'm looking for OpenSSL 1.0.0.7 with this publisher's public key token, the public key of their certificate. When we embed that information into the executable, Windows, when it goes to load the DLL, will look up that and go, oh, he's looking for this one. It goes up to side-by-side, finds the exact version of the DLL they want, and the publisher has the option of having a publisher configuration policy that can say, oh, well, we've got an update to that one. It's 1.0.0.8, and you should be using that one instead. And this facility, which is extremely difficult to use, the way that Microsoft built it and whatnot, is very flexible and allows us to have very strong dependencies and avoid DLL hell. Because even if you have 3 DLLs with the exact same name, the OS actually knows which one is which and will not have a conflict. And our tools make this trivial to use. This is what I've actually spent the vast majority of my time doing, is making it so that you can use these features without knowing how they all work. But if you want to know how they work, I can explain it to you. I've gone to the pain and suffering of understanding this, and one of the people on my speed dial at work is actually the maintainer of side-by-side in the Windows Server organization. So that solves our DLL hell issue completely, and you won't ever have to worry about the wrong one or a poison DLL file or the wrong file in the location. Side-by-side makes sure that you're getting the one you want, digitally signed by the vendor that you want, and the version that you want, or the best version available for that one. Awesome. Is that it? We good?
I've got another question.
Oh, one more question.
It occurs to me that if you targeted, instead of going straight to Visual Studio, if your build analyzer targeted CMake instead, you'd produce an intermediate thing that could then spit out Make or Visual Studio versions of almost any kind. Because CMake have already done the work to do the sort of and now convert it into a project file stuff.
Yeah, we can target. We haven't actually built our intermediate format for that yet, so ideally we could just target CMake and have it do the work for that as well, absolutely. I don't really want to reinvent the wheel in that regard, with the exception there are some features that I want to be able to access that CMake doesn't quite deliver in the right way that I'd like to see it, but that certainly is a great way to help make this work as well, is just target CMake and then have CMake target multiple compilers. But we need to make sure that CMake knows where to find all of our libraries and things like that as well. The front mic is not on. Oh, there it is.
I have a question. You've told 3 or 4 times right now that it's a really hell to do the side-by-side and you don't know it. Why don't you document it then for the server? That would be a good goal for coapp.
I have very little time I can barely get half of my own stuff documented. While I would love to, and what I might do is actually write a few more articles. I've written a couple on my blog, which is at fearthecowboy.com, about talking about side-by-side. And I would love to document it a bit more, but I am running out of time. I'm working 6-7 days a week on this stuff, between 8 and 15 hours a day. Mainly because it's my passion, but also because I'm really trying to get this stuff done before somebody says, well, let's make some crappy solution because let's do it this way. No, we got to get it right. So I'd like to. I really would. Okay, cool. Thanks, guys. I really appreciate it. And you all have a great FOSDEM.